Okay, this is my primer on electric fields. So this is your electric field equation. So this says that the electric field is the change in electric potential divided by the change in distance. And that's in volt per meter. So in air, if you get over 3 times 10 to the 6 volts per meter, then the air breaks down and becomes a spark. Okay, so here is one way to make both a high electric potential and a constant electric field. So here I have two pi 10s. This doesn't work perfectly, but you get the idea. And they're hooked up to a Van de Graaff generator. So if you haven't seen one of these, this is a very simple device. It has a voltage down here with this rotating belt, and that carries electric charge up into the sphere that then goes on the outside of the sphere. So this gets highly charged with a high potential. Now, so this plate becomes charged. This plate over here I have connected to ground. So this will pull, I think this is positive. I'm not sure which charge this becomes. Let's just say that's positive. And this will pull negative charge from the ground, and so they'll be separately charged. And if you get these flat and parallel, then you'll have a constant electric field in there. The closer you get them, then the greater the electric field, because you're decreasing the distance. Or you could increase the electric field by increasing the voltage. So let me just run this, and then you can see what happens. Let me scooch it forward here so you can see. Okay, I'm going to turn it on. I hate getting shocked, so. Okay, so you can see you see that when they have opposite charge, they get attracted. So I have to tape these things down so they don't move towards each other, but they spark. The sparking rate depends on how far apart they are, because the further apart they are, the longer it would take to get up to the voltage to create that electric field. But when they're closer together, it doesn't take as long. When it sparks, and it discharges, and it's got to start over again. Okay, so let me just discharge these by make sure they're okay. So that's one way to do an electric field. If I move these further apart, let's just do it and then turn it on again. And you'll notice that the closest point is where they spark, because that's where the electric field is the strongest. Move these together. Okay, now they're discharged. Okay, so that's one way to make a constant electric field. The other method that was mentioned is this. This is a Tesla coil. So this has a coil of wire in it that has a changing electric current that generates a high voltage, and then you can make a spark with this end. It's pretty fun to play with, but not necessarily as useful. Let me go on this side, and I can just plug this in. Okay, so that's the Tesla coil. The big difference is this makes a changing electric field, and that's a constant electric field. So there's your electric voltage primer.